Okay, I just put a link to an article, a draft article I just wrote in the chat. And this addresses specifically the argument for how to maximize REV utilization and relies heavily upon both mathematical and existing data that we have about networks. So I will walk us through that now. So just a reminder that our chain's value prop only works once we get to significant transaction volumes. And we've been open and above board about that from the get-go. In many ways, it's like a lot of Web 2 properties, right? So Facebook was bleeding cash for its first 10 years. WhatsApp was bleeding cash for its first 10 years. So investors put, hundreds of millions of dollars into those companies before they saw a penny in profit. And that was over a period of 10 years. So our chain's proposal, basically the argument is to get to profitability much faster at a much lower cost to investors. But what we have to do is to demonstrate a path to the kinds of transaction volumes that we're talking about. So specifically, what we're saying is roughly we need 3 orders of magnitude greater transaction volumes than we see in networks like Ethereum and Bitcoin. So at those volumes, validators can charge 1/100th of the transaction fees and still make 10x the revenue of those miners. And so just to be absolutely clear, the combined transaction volumes monthly of Ethereum and Bitcoin are in the millions, low millions. And so 1,000 times that is the low billions. So we need to get to billions of transactions per month. And if we can do that, and at the same time, the validators or the companies that would run these validators are able to also see the significant reduction in energy consumption, then the economic equation becomes overwhelming. And so what we need to do is to show an approach. We need to show an approach to achieving those kinds of transaction volumes. And the way to do that is to understand how networks are structured and how they evolve. Once you understand how networks structure and how they develop over time, and you ground that in the math and the science, then you can understand why our chain has the architecture that it does, and that we actually have a go-to-market strategy that is superior to other chains. So the first thing we want to do, if this is the value proposition, is we want to check to see that this is actually possible. Is it even possible to get to billions of transactions per month? Is this practical, or does that require, like years and years and years of development? So the first thing is to rethink the source of transactions. So you've all heard me say this before, but it bears repeating, especially for many people in the blockchain space. If you look at your own behavior with your own computing devices, whether it's your mobile devices or your laptop or your desktop, the question you want to ask yourself is, how often are you clicking to pay versus how often are you clicking to play? By which I mean, how often are you clicking to access or update data in some cloud-based service? So let's run some examples. Are you clicking to pay when you use Gmail? What about Google Maps, WeChat, Telegram, Facebook, Twitter? These are all examples of networked services for which the data access and update transactions overwhelmingly dominate the financial transactions in number, right? So You can run the math. You don't have to believe me. You can check it out and just look at your own behavior. Data completely, overwhelmingly dominates financial transactions. So if you want to get to billions of transactions per month, you need to look at data as the source of your transactions. Okay, but now there's a second. Go ahead.
Please, could you make the font just a bit bigger, please?
Yeah, sure.
Yeah, okay, that's great. Thanks.
Sure. But now suppose that so we see that if we shift the source of transactions, that it becomes more, we can contemplate getting there, but there might be coordination costs that create an insurmountable barrier to getting those volumes of transactions, right? So for example, Google paid an enormous coordination cost to get to the point where it had the world's largest supercomputer. So maybe building the world's largest supercomputer is the only way to get there. And that means that only a very few can ever get there. So is it possible to get there? So let's check it out. So let's consider just one application of this kind, right? So imagine that there's a group of people, I don't know, like Daryl Newdorf and his cronies who want to build a decentralized version of Spotify. Like, how big do they have to get to 1 billion transactions per month? Well, suppose they could land not 1 million artists, but just 100 artists, each of which has an audience of 1 million followers. That's 100 million people, assuming the artists don't have too much overlap in their audiences. If each of those people listens to 10 songs per month, which is extremely conservative by comparison to Spotify numbers, that's 1 billion transactions per month. Further, it turns out that the fastest growing sector of online music is the small to medium artist who has audiences in the range of 1 million followers. So it's not only that we can imagine doing this with a very small effort by comparison to Spotify. In other words, you can see a path to jumpstarting an app like this. It also, doing that matches the way the market is developing. Now, it turns out that online music is only one example of many, many services that are about content creation, from video to journalism. And there are tons and tons of existing services that you can see for yourself fit into that category. So again, getting to 1 billion transactions per month is entirely feasible within this market. Okay, so we've shown that if you switch to data, and then you take a particular approach to the market, you can get to those numbers relatively quickly, certainly more quickly than Facebook did, or WhatsApp did, or even Spotify. Okay, so now there are, of course, technical feasibility questions, and I'll only touch on those briefly because mostly I want to focus on the economic picture and why the economics works the way it does. Okay, but obviously, if you were going to build a decentralized Spotify, it's not decentralized if you're keeping the audio data in a centralized backend service. It's just, and so if you're not, who cares, right? Like, why switch to Spotify? Why switch from Spotify to your service if you're not actually decentralized? And moreover, if you're not decentralized, so you're hopping from, say, Ethereum to something like IPFS, then you've lost the ability to easily search for songs or podcasts or whatever, right? So the whole point of Rolang is, from the beginning, from when I conceived of this architecture in the early 2000s, the whole point of Rolang is to provide search capabilities in a decentralized setting, in a chain that can actually store the data on chain. And our chain has shown that it can store and stream both audio data and video data on chain and stream it from chain. So again, it's at least feasible. So there are all kinds of other things that'll get in the way, but at least if we do the back of the envelope considerations, right, it's not crazy. Okay, but it's really important to understand how this relates to maximizing the utilization of the REV. So this is where the power of the group is so important, right? So if we think for a moment about Facebook groups or WeChat groups, or any of these other social media things that offer groups and pages that many people can join, you might ask yourself, well, yeah, so what? You know, how many groups are there by comparison to how many users there are? I mean, there are billions of people on the planet. How many groups could there be? Right. So if there are 1.5 billion Facebook users, there are 2 to the 1.5 billion possible groups. Now that's assuming that people don't make more than one group with exactly the same members. In fact, they do often do that. So that astronomical number of possible groups is the minimum number of groups, right? So think about that. If you have a flat community of N participants, there are 2 to the N groups, right? So if you have a community of Alice, Bob, and Carol, and each one of them wants to spend 1 REV, you have a demand for 3 REV. But if each sub-network of that community, right? So not just Alice, Bob, and Carol as a community, but also the Alice Bob community and the Alice Carol community and the Bob Carol community, and so on. Each wants to spend REV. Then you are looking at a demand for 8 REV. And it only grows faster and faster, right? So if we've abstract away from this, you know, this picture of this network like this, and just start drawing them like this, well, when we add 1 more member to that community, then this is how fast, how much it grows, right? And then if we add 1 more member to that community, right, this is how big it is, right? So, but it's important to not look at this just in terms of the network, the growth of the population of subnetworks in relation to the flat community. The picture is also useful to talk about evolution. So in particular, the coordination costs of coordinating 2 to the N people quickly becomes prohibitive. And everybody knows this. This is all common sense. What do? We break those 2 to the N people into groups, right? That's why Facebook groups exist. But it's also why cities exist and counties exist and provinces and states exist and nations exist. Because the coordination costs of coordinating N shards is much lower than the coordination cost of 2 to the N people, right? So it's not just about building up networks, it's also about decomposing networks so that you can maximize the concurrent development of subnetworks and minimize the time it takes to build the public network. So if we use just this picture right here, can you see my mouse?
Yes.
Yes. Okay. So if we use this picture right here, right, each one of these subnetworks can develop on its own in parallel. They can develop their own private shards. And then they have 1, 2, 3, 4 coordinating events to wire into the top level shard. So the argument is we get to the public network faster if we let each of these subgroups independently develop their own private shards. And this is just common sense, right? It's how the world is structured today. Okay, so But now this is really a picture of subsets, and subsets are not subnetworks. So in particular, in the case of a utility token like the REV, which derives its value from the cross shard communication, right? What makes a network versus a set is because you have communications amongst the members and amongst the groups. And so you want to ask yourself, where are the bulk of the communication events? And you can kind of see what's going to happen, right? So down here at the leaves, there's almost no reason to do cross shard communication because there's no contact point, right? So Alice doesn't have a contact point with Bob, right? But Alice Bob has a contact point through Alice with Alice Carol, right? And so in general, what we'll see, and this is borne up by the data, is that where you have a balance between overlap and autonomy, that's when you start to get actual cross subnetwork communication. Now, you might think, well, doesn't that mean that most of the communication across shards is going to be somewhere in the middle layer, below the top layer, but well above the widest point in the network? And from a purely theoretical argument, that would turn out to be true. But in reality, if you actually look at how networks form, it turns out that's not what happens. What really happens in actual networks, whether they are the result of human design processes or evolution, right? So here are two examples of such networks. One is from livestock distribution, and the other is from some design network. The point is that you typically get a backbone and a lot of subshards connected via the backbone. So these are what are called small world networks, identified by Strogatz and others, studied extensively. And RChain's architecture and proposal is to have mainnet be the backbone. So REV is the backbone of a small world network. And that allows the shards to develop autonomously and independently without coordination costs amongst themselves. And then the value of becoming connected becomes very, very apparent. And so then they connect. And once they connect, then you get maximum utilization of the REV. And this is provable. This is not some airy-fairy idea. This is a fact about both the math and the science of how networks are structured and evolve. So the next piece of the puzzle here is that you have to convince the dApp builders to build on your platform. And that takes, as we have seen, a lot of time to get people to understand what your platform offers and why they should begin building, especially in the context of an existent large-scale incumbent like the World Wide Web. And this is where the enterprise strategy comes into play. So the main point is that there are soft supply chain management problems where the enterprise sector gets small world networks much faster and much better than B2C markets do. So let's unpack that statement. So what do I mean by soft supply chain? So softness is a qualitative term to describe the measure of risk to transaction volume. So risk in certain markets with respect to certain transactions is very high, right? So if you talk about in the world of biology, When a single-celled organism is following a trail that looks like sugar, looks like food, it might be poison, right? And so there are specific biological strategies for how to navigate that kind of world, and it results in these kinds of network evolutions. Similarly, at the level of supply chain management in human networks, what we're talking about is the difference between, for example, the financial markets, where the failure of a single large dollar ticket transaction can be catastrophic, or the failure of a day's cycle of smaller transactions can be ruinous, right? So that's high risk and relatively low transaction volumes. By comparison, you know, there are billions of Facebook posts every day, right? And nobody is going to die if a Facebook post or a Twitter post drop on the floor. No one's going to get bent out of shape if a Spotify song, gets dropped on the floor and it has to be delivered the next day. So that kind of softness is what we mean in the online sectors, but there are similar versions of supply chain management problems where they're soft. So if you're talking about popular print media, as an example, no one dies if the tabloids get delivered to Tesco's the next day, or if the the latest paperback romance doesn't hit the bookstore on the high street until next week, right? Nobody dies, right? So that's what I mean by soft. You have transactions that can fail without catastrophic loss, right? So, but in the case of these soft supply chain management problems, typically the end-to-end solution in these soft supply chain management markets requires crossing trust boundaries. So again, let's look at this simple example of popular print media, right? So typically what you have is a large-scale distributor. In the UK, that would be Smith's News. In the US, that might be one of the large distributors like Random House, right? And then they go over to the next layer of chains, like the supermarket chains, or the convenience store chains, or the bookstore chains, right? And then each of those chains then distributes out to independent and individual stores, right? So every hop in that network is correlated to autonomy, right? So the print media supplier is autonomous from the retail distributors. And in many cases, the actual retail outlets, the convenience stores, the grocery store, are also autonomous from the chain, right? So for example, in franchise model situations. So this level of autonomy is important for coordination costs, which I mentioned before. But the main point is that we have this clear small world network. There's a backbone and a bunch of subshards underneath it, and they cross trust boundaries. So because they cross trust boundaries in an end-to-end supply chain solution, a blockchain fits perfectly. So here you have a situation where you have a blockchain designed to match small world network phenomena being rolled out to a market that is higher transaction volume, lower risk. That's exactly what we're talking about. You want to have autonomous development of the subnetworks so they get their own shards, and then the public network arises because the shards then connect to each other. And the enterprise understands this, obviously, in a way that the existing blockchain markets who are fixated on flat networks don't get. Once you have deployed a handful of these kinds of enterprise solutions, you are already at billions of transactions per month. And in the case of the co-op, you're getting money for deployment of the software to the enterprise, in addition to increasing the REV utilization. So in a case like the one we're talking about, the co-op becomes solvent, better than solvent, financially independent of REV sales, just through interaction with the enterprise. And at the same time, pursues the path to the biggest utilization of REV in the shortest possible amount of time. So the arguments are absolutely watertight in this case. The math and the science completely support this go-to-market strategy. This is, in fact, the analysis that I did in 2008 when I sat down with Fred Fisher and we looked at how to go after these kinds of small world networks. So this is the point I have been trying to get across to a wide range of people in order to talk about rolling out a blockchain at scale so that we can begin to reshape the supply chain markets so that we actually have a resilient, robust, decentralized supply chain in time to begin to mitigate the systemic failures that are going to hit the supply chain as the climate change events begin to increase in frequency, right? So it's very hot in Europe right now, and it is only going to get hotter. And if it's very hot in Europe, you can imagine how hot it is in the tropical zones. And once it's so hot in the tropical zones that it is no longer a place human beings can live, people will move in droves. And that is going to impact supply chains even more than the fires and the floods and everything else, because it's going to drive conflict to make Ukraine, Russia look like a picnic. And as a result, we need to have a robust, decentralized supply chain solution. And so rolling out in this way makes the most sense for our chain's goals and for maximizing investors' return, right? It's very lucrative because it is provably the fastest way to maximize REV utilization, while at the same time bringing money into the co-op. And at the same time, it prepares us for the creation of a robust, decentralized supply chain infrastructure, which is very much at the heart of our chain's goals. Okay, I'll stop there and see if there are any questions.
Yes, hello, Greg. I have a small question. So let's say I set up a shard for a given B2B use case now with like 10 validators. Is it possible that in the future we do a maybe CBC Casper session where we try to, and let's say now I want to connect with the mainnet in order to connect with another shard. I'm trying to picture what it could look like on the rolling level. So it could be great to have a session where we chat about this.
Absolutely. So the basic idea is, you know how in the registry there's a shape to the names. You can see how the names have a particular structure to them.
Yes.
So that structure is augmented with the shard IDs. And once you have shard IDs in your names, you can now refer to channels in other shards. So now you can write contracts that cross shards.
Okay, so so it means that I'll send a message to another network, and how do the 10 validators of my network, how do they coordinate on who will send the message to the mainnet?
So it doesn't matter, right? Because everyone in the mainnet has to agree that the message was received, right? And then everyone in the other shard, every validator in the other shard has to agree that they got the message from the mainnet.
Okay, okay, I'm trying to get it. I'm starting to get it. Thanks.
Cool, cool. Any other questions?
I have a question about small world networks. I think you said. Is this in the present context like what Facebook or Google is creating with their networks? Are they like present these small bird networks?
So what Facebook and Google provide is the ability to make groups. If you watch the evolution of the groups over time, they tend towards small world networks. And in fact, and in fact, Strogatz and his collaborators have shown that that's in fact the case.
So I was thinking, yeah, you said that they mentioned the backbone. So are they now providing some kind of backbone?
I mean, certainly they are. The backbone is Facebook itself, right? But even if you consider just the small world networks themselves, right? What happens is they form recursively a small world network. And so if you forget about the fact that Facebook is the transport for all of those, for all of the Facebook groups, right? Or Twitter is the transport for all of the Twitter groups, right? If you just watch the groups themselves and see how they talk to each other, right? You'll see that they evolve to a small world network.
I see. And also, I'm thinking in terms of decentralization. For example, decentralization of Facebook. So there is another layer that I mean, inside the Facebook, they must have some kind of coordination, right?
Oh, absolutely.
Which
yeah, that's
can
correct.
be or cannot be decentralized. We don't know exactly, right?
No, we know that it's centralized within a data center and it's decentralized across data centers.
But I mean, they don't need to coordinate between groups inside Facebook, or at least they have some kind of hierarchy where they can say, no, you will do exactly what we decided and that's it. But in decentralized way, we need some kind of additional layer of coordination or decision making.
I don't see that.
I mean, Facebook can decide what kind of machines they want to use in data centers, or if something is good enough, or if they want to pay for something. But in completely decentralized way, maybe some validators can have like a different opinion, and they want to run a little bit differently. So.
Oh yeah, but that's where the incentives of the shard become important, right? So, you know, the calculation of laziness, the calculation of idleness, all of that stuff suddenly becomes important, right? So if you're not producing blocks at the right rate, or you're disconnected too often, all of those things go into whether or not you are not slashed, but you know, pushed to the side in the shard. And so then you let the market duke it out, right? So if there's a bunch of validators who are able, because they have invested in hardware, to dominate, then the other validators will get pushed to the side. They'll get ejected, and then they lose money because they tried to participate to get transaction fees. They provision all this hardware, and their hardware is sitting idle, so that punishes them, right? Mm-hmm. And so then the economic incentives are such that they keep up with the Joneses. Right. If the Joneses buy a Cadillac machine, everybody else is going to buy a Cadillac machine because they have to keep up, or they get punished financially.
I mean, I'm a little bit concerned about how today people are not interested in to run their own networks, and this is why Facebook has a much easier way to.
No, I agree 100%. I mean, that's just horrendous. But that's why that's why we focus so much on concurrency, right? Because what the hardware market is delivering over time is more and more machines that can handle more and more physical threads at in a smaller volume at lower power consumption, right? So it becomes possible in the next 5 years, assuming we don't have really bad catastrophes climate-wise, we'll see, machines, we'll see the equivalent of the 100 core machines at 1/10 of the cost. Mm-hmm. And so, and a much smaller volume. So you can build out, what would be a really high throughput shard today underneath your desk in 5 years. And so then it becomes quite cost effective to not have all your eggs with Ali Cloud or Amazon or whatever.
So you're saying that people don't need to put some kind of special effort. They can just put some kind of box in their home, and basically they are participating. That's it, right?
What I'm saying is that's the trend. Of course, obviously the high-end machines will now be exponentially better, right? But I mean, it's just like today, your phone has many times more compute power than was used to send people to the moon, right? In 5 years, the stuff you can put underneath your desk is going to be as good as, a 100 node network with 100 CPUs per node, right? And that's going to be good enough to do, Visa scale, right? So you could do Visa scale with hardware under your desk. Now, will that run the metaverse? No, it won't.
I mean, I'm not necessarily thinking that, we need to have these machines at home, and I'm thinking from the perspective of why we as a group of people cannot own a data center. So in that case, I don't need these machines at home. We are just, as a group, we know that we need these large data centers to run our world, right? Like a metaverse.
No. I totally agree. So so there's another business thing that our chain has contemplated since 2017 that is kind of data center in a box, right? So you make a franchise like McDonald's that you roll out to the US Midwest where they stand up a data center, right? And they're supplying compute to these different networks. So it totally makes sense. I would love to put money in it. It's a matter of shaking loose the resources. But I mean, this is something that we have thought actively about and would love to pursue. It's just like there are too many things to it's like you can't boil the ocean. But yes. But the important thing for me is there are a bunch of people in the Chinese community who don't get it, right? They think that building a flat public network is going to be the way to maximize REV utilization. And it's just a crock. It doesn't stand up to any analysis whatsoever. And you can just look at the numbers in Ethereum and Bitcoin. Look at the total transaction volumes, right? You know, Bitcoin has been around since 2008, right? So we're, you know, it's getting quite long in the tooth. What are the transaction volumes? They're not in the billions, not even close. That's off by 3 orders of magnitude. So if you want to get to the billions of transactions per month, you have to take a different approach to the network evolution. And this is what I've been trying to talk about for a very long time.
Yeah, maybe
Well,
this is driving. Maybe
just
this
wanna
is driving by.
Please
Okay,
go.
please.
I just want to say that like there are different types and kinds of transactions, low cost, high cost, and maybe in general, blockchain community, there is a bias towards seeking for high cost transactions. So that's why total locked value metric is widely used. So it's more like, that's why the main bias is towards financial transactions, because they are sometimes very costly. So you can get a high fee from a single transaction. And our chain is seeking towards billions of very low cost transactions.
Yeah, but you can see, right, that was the whole point of soft distribution, right? If you're low transaction volume, high risk, right? So if you're putting high dollar value in a single transaction, then if that transaction fails, right, which is more and more likely, you know, over the lifetime of the network, until you have, you know, until you've nailed up all the bugs, right? So the likelihood at the beginning of the network's life, you're going to drop a transaction on the floor is extremely high. And so the cost of failure in these high risk transactions that can destroy the entire network, right? If you drop $1 billion transaction on the floor, right, and a bank gets very upset with you, you're toast. You're not going to do work in that market sector for another 10 years. But, you know, if you do billions of transactions, right, then, you know, in a low risk setting, then you can achieve the numbers without the risk. And that's what Web 2 was all about, right? I mean, like, look at every single Web 2 service that is, you know, one of the world's largest companies today, right? Google, Facebook, you know, Amazon. They're all high volume, low risk.
Sure. I have one technical question which bothers me for quite a while.
What's that?
Like the state, how exactly would the state look like in the sharding environment? So you're saying that if you have a shard ID and you can prefix a name with the shard ID, you can get access to this name. But this means that the gateway between two shards have to store the full tuple space of these two shards.
No,
like
no, it only has to store the namespace that's common to both.
How it's common if two shards have different prefixes, so they don't have common names.
If I have a transaction that uses a name in shard A and a name in shard B, right? I only have to shard the state. I only have to store and agree the state involving those two channels and nothing else.
Yeah, would be nice to have some write up on this, because I mean,
just think about it, right? If I got it, so there's only two cases. There's input and output, right? So if I'm doing an output, you know, from shard A to shard B, then the parent of those two has to know about that data on that channel and nothing else.
Yeah, it can be any channel
Yeah.
on shard A and shard B. So you have to have fault tuple space.
No, you don't have
because
to, you only have to have the channels that cross shards, and that's it.
How do you know that?
to-
which are cross shards? Yeah.
But you know which ones cross shards because you can see through the name of the channel and the name and where an agent resided, which shard an agent resided that used that channel. You can see exactly what crosses shards.
But there must be some kind of coordination for validators to understand which shards they want to participate, and also I think
Absolutely, yeah. They have to be able to be bonded in all the right shards. That's correct.
Mm-hmm. And I think that Anton concern is if you don't have the whole state, basically you cannot calculate the root hash of the Merkle tree. But maybe this can be done some different way, right?
But again, you don't need the root hash of the Merkle tree for the parent shard. All you need is that the root hash of the parent shard include the state that's common to the two shards it's coordinating. It doesn't care. It doesn't care about the rest of the data, right? It only cares about the data that's going from one place to another.
I see. So the state of the parent shard it doesn't include the child shard. It only includes somehow the transition of the specific transaction of the child shard or between child shards.
That's correct. There you go.
Yeah, I'm imagining that if you are going between the child shards, communication is definitely slower. I mean, it must be the case.
It has to be. Yes, yeah. It has to be, right? Because you're involving more parties. I mean, it's just like look at nature, right? Like the reason there's the formation of a cell is because sometimes you need signaling to be fast. And so that's what happens inside the cell. And then there's communication between cells, and that's going to be slower. It's like it's got to do more things to get from one cell to another. That's just like, you know, it's physics and biology all at once. Physics and chemistry, biology all at once. There's nothing. I mean, it's like there's no magic here. You just gotta follow the rules, right?
Yeah.
Greg.
Yes, go ahead.
Yeah. So something about B2B, like working with B2B. So I think all B2B services have strong, requirements about confidentiality. So just like you can have a private IT and send messages to the internet when you are a company, I think it's important to explain that we can do the same with shards. We can have a private shard, but the message is going to other shards. Of course, will be public, but we can keep the computations private.
Exactly. That's exactly, that is, it's absolutely critical that we have this capability, right? And it's just, and again, it's like, we don't see the inner messages inside Google. We don't see the inner messages inside Facebook, right? But we see lots and lots of engagement, between a business and Google, or lots and lots of engagement between a business and Facebook, right? So it's just like that. You have to be able to have these security boundaries and be able to cross the security boundaries. And so that's why the architecture has to look in the way that we're describing.
Yes. Yeah. The point is that I think if this is explained earlier in your argumentation, I think it's even more powerful for business people.
Oh, I agree, but right now I'm just trying to get the flat public chain people to understand that they're never going to get where they're trying to go unless they do sharding. You can't do it, right? And the coordination cost of building the large scale public network is so much lower if you let it emerge by connecting a bunch of shards. Right. So the issue is that people think, oh my God, you know, like REV is never going to be of any value because everything's happening in the shards. Wrong. Right. And like the way to see this is just go look at any online transaction you're doing and how many subsystems it actually touches. So if you're, you know, if you're booking a trip through Kayak, you're touching the airline, you're touching the rental car, you're touching the hotel, right? But even if you skip Kayak and you go straight to the airline, well, guess what? The airline is touching the identity validation shards, you know, the government shards, you know, to make sure that you know you're not a wanted person, and so on and so forth. Right. So there is no transaction you're doing online that's completely isolated. It's always touching, you know, tens of other subsystems. And kind of this is the point I've been trying to make, is this is why it's called small world. There's a backbone, and then there's lots of these shards that are all connected by the backbone.
I think that, for example, Ethereum, what they are doing is it looks like it looks like this public flat architecture. But if you look more closely, I mean, they are describing the only 64 shards, right? Which is immediately it's strange. Why like a finite number? But how they are looking at the future is basically we will have some kind of zero knowledge proofs. And everything, all computation will be somewhere else, and we will store hashes on the flat chain. But just looking at that is saying we cannot run everything flat, right? It must be somewhere else.
Yeah.
So having some kind of tree structure, it makes makes sense for me, because you can shape your tree as you have demands, right?
Oh yeah. Yeah, exactly. And guess what? You only have to walk outside your door and pay attention to the way the forest looks to see that, you know, this is common sense, and the data is overwhelming.
Yeah. From my perspective, I think the bigger problem is going to be to move people from the root. Then in other direction, because what we see now is we want to have decentralization, but it's difficult because it's much easier to use roots for everything, right?
Yeah, I agree with you. I 100%. Yeah. Tree reconfiguration is an important tool. Yeah.
So, Greg, to kind of follow up on Raphael's point about privacy. So shards give us privacy, say at some kind of an organizational level, but what is our scheme for transactional level privacy? Because that's, I think, is also an important consideration in the enterprise environments.
I mean, all the transactions that use resources that are not visible to other shards, they're all private, right?
No, that's what I'm saying. So that's within a shard. I mean, but certainly we are not going, our answer is not to say one shard equals one transaction, right? I mean,
No,
is there a lower, more granular privacy that we can offer?
All the names inside a given shard that you don't make public are private.
Mm-hmm.
So you can have
so it's
as many private, as many private, you know, transactions as you want. Just don't publish those names.
Okay.
Right. And I mean, the beauty of this approach is, you know, I'm thinking of a URL. You have a week to guess it, and you can use any resource on the internet you want. You know, what's the likelihood that you can guess my URL? 0. Right. So it's got as much security as you want. Right.
And for that, I guess we really don't have to do much more technically.
No, I mean, the architecture already supports that. There's nothing else you have to do, right? The only thing we have to do is to make sure that, you know, the name structure includes the shard ID as a part of the name. But apart from that, there's no other change we have to make.
Mhm.
I'm just like with regards to the state. So have the parent shard validate all blocks in all children shards.
Nope.
So it does not validate.
It only validates the cross shard transactions.
But how which route it is computing, which, so we're computing Merkle trie.
So
What is the
again,
Merkle trie?
the parent does not care what the child thinks about the root shard, right? So think about it like this. I've got two message passing applications. Let's call it A and B, right?
Mhm.
So when B receives the data from A, it doesn't care what state A has. All it cares about is the data that was sent. So A can have, all kinds of state that it's storing, but B only sees the data that went out of A.
Mm.
And then you say data, that this doesn't have to be like complete data. This can be just a hash of the
Correct.
data also, right?
It could be,
Mhm.
but if you do straight up message passing, you make a copy of the data when you leave the child shard and go to the parent. Right?
Mhm.
And that's totally fine. That way the parent is isolated from the child.
And parent must have some kind of acknowledgement from both parties that transaction succeeded or not.
You just have to know that the transmission was complete, right? So that's like rabbit, exactly once in order, durable communication.
And finalization in that case, how finalization is connected between the parent and the child?
So the only thing that matters is, did the parent finalize the transmission of the data? Did the child finalize the sending of the data? As long as both of them agree on that finalization, that's it, right? They don't care about anything else.
So is this creates some like I'm wondering what defines this additional latency? Is this involved the finalization between them? This makes sense.
I don't know what by additional latency you mean. All I'm saying is they both have to agree that the data was sent and the data was received, and that's it.
I'm more thinking like interaction between consensus on the parent and the consensus on the child.
But again, the point is that you don't have to have a consensus agreement as long as you have exactly once in order guaranteed message delivery.
Oh, I see. I see. So the parent doesn't need to somehow support consensus on the child.
Nope.
This is not
Not a requirement.
Okay.
You may optimize that way, but as long as it's exactly once in order delivery, then you don't need that. All right, it's 8:01. Thanks everyone. We'll see you in a dev center.
Yep, thank you.